Some of the services you define may need to access unmanaged resources and memory, or they may interact with types that do so. In C#, such types are expected to derive from the iDisposable interface and implement it so that the resources can be released and cleaned up appropriately. When applying these concepts to our code, we must implement the dispose pattern. If you want to learn more about this pattern, I suggest viewing Elton's course, iDisposable Best Practices for C# developers. Consuming code can signal that it no longer requires a disposable type with a using block or using statement. These language features ensure that the dispose method is called on the iDisposable type when our code no longer needs it. The Microsoft Dependency Injection container can handle iDisposable types correctly by calling the dispose method on instances at the end of their lifetime. This occurs automatically for any types that implement the interface and that the container has created itself. As we'll see later, it is possible to pass instantiated instances to the container during registration, rather than allowing the container to create instances of the type itself. In this situation, the container will not call dispose on the type, because it doesn't own the creation and therefore the lifetime of the instance. To demonstrate disposable services, we'll add a new class to the project and call it Disposable Service. We'll add the iDisposable interface to this type and use the Visual Studio tooling to help us implement the interface. It adds the required dispose method to the class. To track when instances of this class are disposed of, let's accept an iLogger via its constructor. Inside the dispose method, we'll log a message when it's called. We can update the index model for the home page to accept an instance of the disposable service. I don't have an interface for this, so I'll accept the concrete type. The Microsoft Dependency Injection container can support injecting concrete types, so this is fine. We need to assign this to a private field. We won't actually call any methods on the service, but it will still be injected when the application invokes the page model. Because we only have an implementation type, we'll use an overload of the addScoped extension method that accepts a single generic argument. The generic argument represents the service type that classes can depend on, but it's also the implementation type that the container will create when instances are resolved. Returning to the program class, we can register the disposable service with the iService collection using the scoped lifetime. We can start debugging the application, and once the application starts, the homepage loads. I'll hit F5 to refresh the homepage several times. If I switch to the Visual Studio Developer Console, then we can see the logs from this application. There are multiple messages from the disposable service showing that the dispose method has been called, and this occurs once per request. The dependency injection container creates an instance of the disposable service for each request, because we registered it as scoped. Because the service implements iDisposable, the container ensures it calls the dispose method where unmanaged resources would generally be released. If we change the registration to set the service lifetime to singleton, we can observe the effect. This time, after the application loads, I'll again refresh the homepage several times. This time, when we review the logs, we see none from the dispose method because the singleton instance remains alive and therefore it never gets disposed. When the application shuts down, disposal for any singleton services can occur. .NET Core 3 and C# 8 introduced a new interface called iAsync Disposable. This allows types to implement the dispose pattern asynchronously. The team at Microsoft introduced support for iAsync Disposable types in .NET Core 3 so that the iService provider can handle their lifetime correctly. But there was one limitation. Types that implement iAsync Disposable but not iDisposable could not be supported from scopes created by the iService provider. Now this of course impacted ASP.NET Core applications because they rely heavily on scopes to achieve per request instance separation. The reason for the limitation was that the iService scope type, representing a scope from the service container, only implemented an iDisposable and not an iAsync Disposable interface. The dependency injection abstractions, including iService scope, form the basis of the conforming container contract. Therefore, adding the new iAsync disposable interface would change the contract, and it would require downstream changes from any third parties who derive types from the interface. In .NET 6, a PR was merged, which solves this by adding a new extension method on iService Provider called createAsyncScope. This returns a scope, but wrapped inside an async service scope, which is a new type and therefore can implement iAsync disposable. This wrapper can determine if the iService scope implementation it wraps supports iAsync disposable, and if so, call it appropriately. Otherwise, it falls back to calling the iDisposable method instead. The built-in Microsoft Container implementation supports iAsync disposable, and therefore in ASP.NET Core, we may register scope services that implement the iAsync disposable interface. We can use the sample application to see asynchronous disposal in action. We'll add the iAsync disposable interface to the disposable service class. We must implement the interface, which, for this demonstration, will log to the console when the method is called. We need to return a value task for this method, so we can use the cached completed task in this simple example. After rerunning the application and viewing the Visual Studio Debug console, I'll press Ctrl+C to cause the shutdown of the application. As the process is exiting, the service provider calls the iAsync disposable method on our service to cleanly dispose of it. The non-async method is no longer called because the async method is preferred when one is available. To conclude this module, we'll finish the initial service registrations for the tennis booking sample application. We'll apply the techniques and knowledge that we've covered so far in order to achieve this. I'll first ensure that I set the tennis booking application back to being the startup project, and I can now press F5 to launch the application. The homepage loads, and I can log in using the member@example.com username. Now, if you're following along, the password is just the word password. As a logged-in member, I should be able to view my court bookings. However, when I attempt to load that page, we now see a familiar exception. The page model depends on an iCourt booking service, which we have not yet registered with the dependency injection container. It's worth calling out that the application started without an error, and this exception only occurs when we attempt to visit the Find Available Courts page. Keep this point in mind, as we'll come back to that a little later. For now, to fix the exception, we need to register the court booking service back in the program file. Before we do, let's look at the implementation for the iCourt booking service interface. It depends on two services, an Entity Framework DB context and an iUTC time service. The time service implementation here is very basic, and it has no further dependencies. We're going to need to register all three services before the application can function, and we'll start with the iCourt booking service. Which service lifetime should we use? Well, we saw that the implementation depends on an EF-Core DB context. Earlier, I mentioned that the DB context is registered by Entity Framework as a scoped service. Does that help you decide? That's right. We need to ensure that we don't capture this scoped service for longer than is intended. Therefore, we can't use a singleton registration here. Next, what about the iUTC time service? We saw that that had no dependencies and no state, so we can actually reuse a single instance of it for the life of the application. And remember, it's safe for the scoped iCourt booking service to depend on a singleton iUTC time service. We also need to register our tennis booking DB context, but in fact that's already registered. The code hidden in this internal setup region adds the DB context using extension methods provided by Entity Framework Core. So hopefully we have everything we need registered, and we can rerun the application to confirm this. This time we can successfully load the My Bookings page because the container can resolve all required services. So let's book a court. Oh, we're not quite done yet. This page depends on an iBooking service, so let's return to the code to register that. When we rerun the application, an exception is thrown, but this time we see the exception in Visual Studio during debugging. The message is quite verbose, but the inner exception is the same invalid operation exception that we've seen before. It states that the booking service depends on an iCourt service that we failed to register. So why is this exception thrown here and not rendered in the browser? The Validate on Build property on the service provider options is enabled by default in the development environment. When this option is enabled, a check is performed during the build service provider call, which verifies whether all registered services can be fully created, including any dependencies that they have. This occurs when the service collection builds the service provider, and that's triggered by our call to builder.build, where the exception is eventually surfaced. A reasonable question is, why did the previous exceptions appear in the browser and not at this call site? The answer is that ASP.NET Core activates controllers and Razor pages on a per-request basis, and by default, they're not registered directly with the DI container. As a result, their dependencies are not evaluated during the Validate on Build process, which can only detect errors for services directly registered with the iService collection. We'll revisit this point in more detail in the Injecting and Resolving Dependencies module. To resolve this exception, we must add the missing iCourt service registration. It's worth checking what dependencies the iCourt service has of its own. We can identify that it depends on the DB context, which has a scoped lifetime as we learned earlier. So let's fix this registration to make it scoped. We must also adjust the iBooking service to make sure that that becomes scoped too, because it depends on the iCourt service. Having to use scoped registrations is not uncommon in applications requiring the use of Entity Framework. Many services may access the database and therefore need to be registered as scoped, and this condition can cascade to any classes which depend on them. We can now run the application and we can access the Book Court page. I'll try to make a booking for court number 1. Another exception is thrown because we have yet more required services. The exception only identifies the iCourt Booking Manager, which is the first of the required services that's not available. The best thing to do here is to go and check the Book Court model to review all of its dependencies. Most of these are already registered, except for the iCourt Booking Manager, but it also requires some configuration injected using the options pattern, so we must remember to register that too. Checking on the Court Booking Manager implementation, it also requires something implementing the iBooking rule processor and an iNotification service. So we can go ahead and add these missing registrations. We'll add a scoped registration for the iCourt Booking Manager. The Court Booking Manager required some configuration. We can use the configure method that we learned about earlier to bind configuration to our booking configuration class. We also need the iBooking rule processor, which I happen to know will need to be scoped. And finally, we need the iNotification service. This stateless service doesn't access the DB context, so it can be registered as a singleton service. So hopefully, we're now done. After the homepage loads, let's try again to book a court. This time, we can go ahead and select the length of time we need the court, and we get confirmation of a successful booking. I appreciate that these last steps might have looked a bit scary. During normal development, you'll add services as you go, rather than registering them all at once. I've shown this approach here so that we could practice implementing the things that we've learned so far. Join me in the next module to learn about registering more complex services for some advanced functionality of the court booking application.